Okie dokes. So today we're going to be talking about a couple of things. The first thing we're going to do is talk a little bit about Docker. And then after that, we're going to launch into integrating Python with SQL, which you guys have already done a little bit of, but we're going to do just a little bit more. And today we're going to be talking about something called Django. But first off, we'll get started by talking about Docker. And more specifically, something called Docker Compose. So would anyone just talk it out? If I have a project that I want to Dockerize, or just like something let's say I want to run some SQL code and some Python code in a container. What roughly do I have to do?
You need to have a Docker file that kind of initiates that when it runs. And
Okay.
make sure that everything, like any dependencies that you'll need is in the Docker image that you pull, I guess.
Anything else? I mean, yeah, that's basically. Oh, sorry, Matt. Go ahead. Yeah.
You'll probably want to separate them and have them in like their own Docker containers, maybe. I don't know, depending on what it is.
Yeah, so I mean, first you have to create your Docker file, then you might have to have a setup.sh file. Then you're gonna need to run at least a couple of Docker commands just to get the thing into a container. Forget about starting up the container and mapping the ports and all that. It gets complicated, right? There's a lot of commands, good number of files, a lot of, some might say, room for error. So there's a really nice way that we can simplify creating, starting, and stopping a containerized application. And this is using a tool called Docker Compose. So a Docker Compose only involves using one file. Basically, in order to get everything up and going. And this file is called a Docker compose.yml or YAML file format. Yes, YAML sounds like a very strange word, and it is. But YAML stands for, you could either say yet another markup language, or YAML ain't markup language, or isn't, but YAML has an A in it, so I guess that's why they say it. And it's basically just a very, very stripped down file format in order to store a bunch of data in key value pairs. So let's go here and let's just create a brand new file. So we'll go Explorer. Oh, there it is. We'll call it docker-compose.yml. Now, there's a bunch of stuff that needs to go in our Docker Compose, and I'll copy it in, and then we'll talk about what all of it is. So the first thing that we're doing is we're saying what version of Docker we're using, and then we're saying that we have a volume called Postgres data. The stuff that's really important is everything in the services area, or as VS Code helpfully highlights it, the services in your project. So the other thing is, if you do all this in VS Code, it automatically knows that if you have a Docker compose.yml, that this is a Docker compose file, not just an ordinary YAML file. And number two, it tells you what each of these things is supposed to stand for. So let's just run through what is in the services, and then we can talk about how to use it. So we're setting up a service for a database, which is going to be in Postgres 15. And we're giving it a couple environment variables. We have a Postgres user, a Postgres password, a Postgres database. We've got some port forwarding going on, and we've got some volumes that are mapping to ports in the container. So before I run through this more line by line, does anyone have an idea for what this Docker file might be doing?
Kind of looks like it's combining how we have been doing our Docker file and the setup.sh stuff, at least for the database portion.
Yeah, pretty much. It does combine those. But more specifically, what does it look like it's doing? Like functionally. Like if I were to run this Docker file, which we don't know how to do that yet, but we will in like 3 minutes. What does the file, what do you think will happen with the file? Or with, it might, I mean, is there a database involved? What's functionally going on when we do this?
It's going to set up a Postgres database called Pokédex DB. Presumably make an image and run a container of it.
Yeah, pretty much. So if we start from the top and go down, right? So services basically says, hey, I want to do some stuff. The DB says, well, I want to create a database. Okay, what are the deets for creating this database? Well, first off, it's going to be on a Postgres image with version 15. So it's the same thing as in a Docker file. You say from Postgres:15 by specifying that that's Postgres. Then after that, we have all our environment variables. So whenever we create a database, we need to say, okay, what user is it going to be under? What password are we going to assign to that user to access it? And what's the database called? Then it's going to set up your port forwarding, right? So you're going to start with the host machine port, which is 5454, just like we are used to doing, mapping to 5432 in the Docker container. And the last little bit is volumes. What volumes lets us do is it tells Docker and Docker Compose, hey, remember that database that I told you to create this Pokédex DB? I want you to persist this database, even when my container isn't running. So persistence basically means that even if I were to shut down my container, the database and the data in it still exists on the host machine. So even if I shut down this container and restart it, I don't have to re-input all my data. All my data is still already in there. So, let's say that you are doing some operations with your database in this container. And then you're like, okay, I'm done working on my database for now. I'm going to log off for tonight. So you shut down your container, you shut down your laptop, you go to sleep, you wake up the next morning, you show back up at work, you boot up your container again. All your original data is still there. You don't have to put your data in an Excel sheet and then import it or use insert into statements. It's all already saved and ready to go. So that is the gist of how Docker Compose works. Do you guys have any questions about that before we talk about how to actually use it?
I have a question regarding the volume.
Hmm?
So the volume, is it like an abstract volume in the container, or is it going to be, is it referencing the volume on whatever VM machine that the Docker daemon is running on?
That's a good question. To my understanding, the volume is something that sort of links between your machine and the container. So I'm not too sure where it lives in the daemon, but the function of it is so that your database in the container, once you close out of the container, the database information gets saved to your host machine. Does that kind of help?
Yeah, that helps. And for something like this, like the DB, or maybe for example, maybe let's say maybe networking. So everything has to be defined on that services block.
Yes. So in the services block, that describes all of the containers that you want to run.
Okay.
So hypothetically, you could define multiple containers in here. So I have my like DB container, I could also define, let's say, DB2, and that is
Okay.
now another container that I'm running at the same time.
Okay. Okay. All right.
Any other
Thank-
questions? Good questions, by the way, Tofik. So thank you for asking.
So,
I have a question. So would this Docker Compose essentially replace the Docker file that we have been using so far, or does it work alongside it?
Yep, this basically replaces it. So the reason that we can use like the Docker Compose is basically a Docker file, but it makes it a little bit easier for you to use. Because again, it just does all of this in one file, and by using the volumes, you can save your database and then go back to it. Okay, any other questions? All right, so let's go ahead and see how Docker Compose works. So let's just do like Docker Compose up. So that's what you run in order to run your Docker Compose. I'm just gonna do -d so we can see the flags that happen. Okay, yep, so it says that the container has been started. I'm gonna go check my Docker desktop, and it does indeed say that it's running. And now we're going to go ahead and just make sure that, remember, the main goal of our Docker Compose YAML file was to create some Pokédex DB database. So before we, quit out of it, we should probably just double check that our database has actually been created. So we're going to do docker exec-it, and then we'll take the name of the container. Then we'll say, let's see, what do we do next? We'll have to do PSQL-H, specifying the host, and it's on localhost. And then we'll do -p for the port, that's 5432. -u is Postgres. And then we'll just specify the database is Pokédex DB. Now, if our Docker Compose did not work, number one, we would probably get some errors here that would say the container wasn't started. But number two is we probably would not be able to enter Postgres and go into our Pokédex DB. Now, obviously, we haven't actually initialized any tables in there, except like these default tables through Django. Or actually, well, forget about the Pokemon app ones. We'll get to that later. But ideally, there should be nothing inside of this database. Here, we'll just rename it. I'll just save this Pokemon DB, Pokédex DB1 for now. But I mean, it exists, and also I probably should have cleared the database before doing the exercise. That's fine. But this also shows you guys that persistence works, because I hadn't originally, when I just ran Docker Compose -up, I basically created a brand new Docker file, and I wasn't in a container, but all of the stuff inside this database, it was all saved from the last time I ran it, which is great. So if you want proof that Docker works, here is proof that Docker Compose works. All right, so we're just going to do a Docker Compose down real quick just to stop it from running in the background. So that way my computer temperature goes down. And now we see that the container has been removed, the network has been removed. And if I try doing this Docker exec, we see indeed that the container does not work. So that was a really brief tutorial on how to use Docker Compose to boot up a Postgres database and how to access it. Are there any questions before we move on to the brand new stuff on Django?
Can you explain the purpose of the D that you put on the Docker Compose up?
Sure. So the -D just basically shows you it helps you see more flags if they're needed or if there's any errors.
Okay, thank you.
Any other questions? Also, you can definitely run Docker Compose up without running the -D. So it's not required. Alrighty, on to the fun stuff. So we're gonna start talking about Django, which personally is one of my favorite things in the entire course that we teach, because it is super powerful. So in the full stack module, I think last Monday, we talked about how to use Postgres and combine it with SQL using scicop G2 and writing code on your own. Now, Django lets you do exactly that, but in a far simpler, easier to read, easier to interface with format. So before we jump into using Django, though, we're going to have to pip install a decent amount of stuff. Now, when we're pip installing things, this is a leading question, by the way. Do I just want to do like a pip install Django to my virtual machine or to my computer overall? Or is there something I need to do first?
You should make a virtual environment.
Okay, perfect. So Matt, how do I make a virtual environment?
I believe the command is python -m venv, and then whatever you want to call the folder. Venv is fine.
Yeah, so I'll just call it venv. Okay, here, we'll switch to my other terminal so I don't have the same problem. There we go. It should work. Okay, there we go. Yeah, apparently VS Code and WSL don't always play the nicest together. So that's why I always have terminals open in both of them. Also, highly recommend just in general, regardless of your operating system, if you're using WSL, if you're on a Mac, if you're on regular Linux, always have two terminal windows open. One in VS Code and then one outside of it. Because sometimes one of them can freeze up on you, or sometimes if you are, let's say you're using one of terminal to run your Docker stuff, you can use the other terminal to do your data processing or something like that. It's always, in my opinion, just really a good thing to have like two separate terminals open at once. Okay, so we've created a virtual environment folder, but I'm not using the virtual environment yet. All I did was make it. So how can I get into my virtual environment now that it's been created? Would anyone else like to answer that? Jordan Anderson, any ideas for how we can start a virtual environment?
Do you need to do source your virtual environment name and then /bin/activate?
Perfect. Yep. So now we're into the virtual environment. I'm going to just go ahead and mirror that in my VS Code as well. Source bin activate. Perfect. And the way that you know that you're in your virtual environment is because it says venv, like before your username and the file path and all that. Okay, perfect. And now we're in. So let's go ahead and start doing our pip installs. So the first thing that we want to install is Django, because, well, Django's what we're playing around with today. Really simple, pip install Django. Hit enter. All right, successfully installed. Django usually doesn't take very long to pip install. The other thing that we're going to do is pip install scicop G2. And we're gonna do the scicop G, scicop G binary. So because that's what we need in order for Django to talk to Postgres. So this is the pip install that Chad recommends we do. So just for purposes of making the demonstration a little bit easier and following the curriculum, we'll just follow the same thing. So pip install scicop G and then binary. You should be okay installing scicop G2 binary like we did last week. But just because I tried this earlier and it works, so we're gonna do that again. And we see here that it's now been installed. I'm gonna just double check that everything I want is on here by doing a pip list. So Django's here, pip is here, scicop G is here, and scicop G binary are here. Awesome. Okay, now let's say that my computer, my computer explodes. Now my virtual environment and I also somehow lose my memory of how to do a pip install. So my virtual environment is now lost forever. Is there any way that I can get these packages reinstalled or have them saved somewhere? The answer is yes. And we can do that using something called a pip freeze. So what pip freeze does is it essentially takes this pip list here of all of the packages that you have installed, and it spits them out into whatever file you want. I'm going to say that I'm going to put this in a file that I'm going to call requirements.txt. And let's just go ahead and see what's inside of that requirements.txt file. We see here that it saves what packages you have installed and what versions they are. Package, version, and so on, which is great because number one, if your computer explodes, you can save your requirements.txt file so that on GitHub or somewhere, so that way when you download your project anew, you know exactly what you downloaded and can restart your virtual environment like that. Number two, it's also great if you need to send your project to someone and you don't want to send them this virtual environment file, which is massive. Also, when you guys are pushing things up to GitHub, and you create a .gitignore file, please ignore your virtual environment folder. If you call your virtual environment venv, exclude that folder. If you call it my virtual environment, exclude that folder. Whatever name you give your virtual environment, when you create a .gitignore file, ignore the virtual environment. It adds a ton of files and it takes forever to upload and download. So that is like my number one, biggest tip for right now. We'll have a few more that come in later. Okay, cool. So we've successfully created our requirements.txt. So that's all saved. We installed Django. We installed scicop G. Okay, so now let's go ahead and talk a little bit about what Django does. So, okay, cool. We're sharing VS Code. So Django allows you to create projects and apps, roughly speaking. So let's say that you have a project let's say that you're working for Amazon. And Amazon, the website, has a bunch of different parts, right? You have your main database for all of Amazon's massive inventory. But maybe you have another database that's just focused on individual users and user account information. And you have a third part that is focused on tracking user analytics. And then another thing for advertising. And essentially, your overall project for Amazon has a bunch of different parts that are all related, but they're not the same thing. Each of those parts is what Django would call an app. So you can have a big project that has a bunch of little apps within it. And we'll see how this comes into things very shortly. So the first thing that we need to do is create a project. So I'm going to say is Python -m Django. Okay, perfect. Yep, that works. So just to make sure that Django is installed correctly, and we see a bunch of different Django commands that we can run. We're going to be doing start project. We're doing Python -m Django. Okay. Not sure why I'm getting a warning there, but Python -m Django start project. And now we need to give our project a name. We're going to start working on a Pokédex. So for those of you familiar with Pokemon, the Pokédex is like all of the Pokemon that you have in your inventory in terms of like the little balls and the levels and the names and other things, but we'll get there. So let's start a project, call it Pokédex project. And we're going to put a space and then a period at the end. This period is really important. If you don't add the period, well, I'll show you in a second, but we've created a period. What the period does is it creates a folder called Pokédex project that has a bunch of different files in it. If we did not put that period there, all of these files that you see would go into our root folder, which is not what we want. So to have nice organization of our projects and apps and so on, after you hit start project, put the period there. It will save you a world of trouble later on. So this is our overall Pokédex project. It's got a few parts. It's got an init.py, which is blank, don't bother about it. We have an ASGI, which also don't bother about it. We have a settings app, which is very important, and we'll go through that shortly. We have a URLs app, which right now you don't need to worry about. But I think in next week or the week after, that will start becoming important. And we have a WSGI, which also don't need to worry about. The main thing for right now is the settings.py, but we'll get to looking at that in a second. Now that we've created our project, the next thing that we need to do is create the app associated to our project. So we're going to do, one other thing. Whenever we create a project in Django, it also creates something called a manage.py. Now, we don't need to go into how the manage.py works. I can send resources to you guys on that if you want later on. But the main thing to know about manage.py is that basically runs a bunch of Django's subroutines, essentially, or like mini tasks. So manage.py will help you interface with your databases. It will help you compile things. It will help you open a Django Python shell, etc. So this file basically never, for our purposes, basically never changes. So we just keep the manage.py as it is. It's very important though that in your terminal, like when you're doing stuff in your terminal, you are in the same level as the manage.py file. So hopefully that's clear, and we'll talk about why it's important in like 5 seconds. So now we've created our project. So we need to now create an app. So the app that we're going to create is a Pokemon app. In order to do that, we're just going to say Python manage.py. So remember, for project, we use Django. For starting an app, we use manage.py. We're going to start an app called Pokemon app. And we now see that we have a brand new folder. So this folder has a couple of things in it. It's got a migrations folder, which has an empty file. We'll talk about what migrations are in 10 minutes. It's got an admin.py, which we don't need to worry about. It's got an apps.py, which we also don't need to worry about right now. It's got a models.py, which we will worry about very shortly. It's got a test.py, which we don't need to worry about, and views.py, which we also don't need to worry about for right now. As we start getting deeper into Django, you guys will be like wizards at how every single one of these files works. For now, don't really bother about them too much. The one that we're gonna focus first on settings.py in our project. And then we're going to go into the app and start doing stuff. So first off, anybody have any questions about Django stuff so far or about getting to this point? I know it might feel a little bit like a fire hose, and that's because Django does get a little technical at first. So happy to answer as many questions as you guys have. All right. So if there's no immediate questions right now, and again, please ask if there are any or anything that you want clarification on. Let's start playing around with our settings.py. Okay, so this doesn't change your secret key. We'll get to that when we start talking about cybersecurity later on. Keep debug as true because we want to mess around and see all the errors. The first thing that we're going to do is change our installed apps. Now, we just created an app called Pokemon app. So we might as well add that to the list of apps right now. So that way our code doesn't completely break. The next thing that we should do is link our Postgres database to Django, which again, also one other thing I should have mentioned, Django is all Python. Django does not have, it's not SQL, it's not JavaScript. Django is Python. So when we're linking our SQL database to Django, we're linking our SQL database to Python code. So essentially what Django lets you do is it lets you operate in SQL using Python constructs. And I'll make it a little bit clearer shortly. Okay, so recall that in our Docker Compose, we set up a database. I'm calling this one Pokedex DB1, just so that, you know, it looks empty when we start. Or you know what? Actually, we'll just keep, yeah, we'll keep it empty. So we'll define Pokedex DB1 as our new database. And then I'm going to go to my settings.py and tell Django, hey, remember, I need to operate within a database. Here is how you're going to get to the database. So the default database that Django likes to use is using something called SQLite 3, which is an alternative to Postgres. However, we're not using SQLite 3, we're using Postgres. So I'm going to copy paste a bunch of stuff in, and then I'll go over what this is in a second. So if we go to our docker compose.yml, which is here, and here, let me see if I can actually split screen. Nope, that looks awful. Okay, well, we'll just do one of them. In the docker compose.yml, what are the things that we set up? We said, hey, here is the username, the password, and the database, and the port. If we go to our settings.py, that's exactly what we're giving it. We're giving it the name of the database, the username, the password, the host, and the port that we're going to access. Now, this looks really, really similar to the way that we access our database using Docker exec. And that's because it basically is the same thing, except all we're doing in Django is we're accessing it using our local host. Whereas when we ran Docker exec, we were executing directly into port 5432. But overall, like this thing and this thing basically do the exact same thing in practice. They connect your local host to your SQL database that is running in a Docker container. All right, so let me just double check. My name for the database is Pokedex DB1. So we're going to change that really quickly. And otherwise, that looks pretty good. All right, any questions so far before we start running things?
Yeah, can you run multiple databases off of this?
Yeah. So we can add multiple. So this is like the default database, but this structure is a dictionary, right? It's a nested it's a dictionary nested within another dictionary. So there's nothing basically stopping me from putting a comma and then saying another database. So you can run multiple databases in Django. In general, for our applications, like we'll usually just run one database, but there are ways to run multiple. And we can talk about that later on as we get into more complicated apps and stuff like that. But to answer your question, yes. Other questions? Alrighty, cool beans. So I'm just gonna go back to WSL real quick and just double check that this is up to date in terms of the folders. Yeah, that looks pretty good. So now that we've told Django what database to connect to, and we have a Docker Compose, I'm just gonna run Docker Compose up just so I can kickstart my container, let everything start running, and then we'll start making our changes. Alrighty, cool. So Docker Compose up, it has run. Post database directory has database. All right. And it's listening, and the database system is ready to accept connections. Well, that means, simple English, the YAML file worked, database has been created, container is running, I can now mess around and do stuff in my database. So usually when we mess around in our database, we're going to mess around in the database using SQL or scicopg. We're not doing that. We're going to mess around with our database using Django. All right, so for that, we're going to go into our Pokemon app. So before, we were doing the setting stuff in the project, but now we're going to go to the app and play around with the models. So when you think of models, you probably don't think of Django or of SQL, but a model in Django basically creates a brand new table in SQL. And we'll see that very shortly. So a model in Django is a class that lets you create a SQL table with various attributes. So we're going to start by importing models, which is our base class. And then we're going to create a class called, let's just call it Pokemon. And it's going to inherit from models.model.
Umar, we just see your WSL.
Oops. Okay, what about now? All right, cool. So we're in the models file in Pokemon app. Just to reiterate in case anybody is slightly lost. So we're now going to create a table of Pokemon. Pokemon? I'm going to say it's Pokemon. In SQL via Python. So normally, when we are inserting into a table or creating a table, we need to specify what our primary key is. Not so in Django. You are not required to specify the primary key because Django will basically all of the time, create one for you. You can change the primary key if you want later on, but right now, this is your first time with Django. We're going to keep everything really simple. So let's add in a couple fields. Let's give our Pokemon a name. So we'll call it name. And we're going to say that our name is going to be a character field. So we'll inherit, or basically like text. So if we type models dot, we see a bunch of different options for field. There's an auto field. There's a big integer field. There's a Boolean. There's a character field, which is what we're using. And our character field, we can put in a couple arguments. So let's say that our Pokemon name is going to have a minimum length of 3 characters and a maximum length of 100 characters. That's a really long Pokemon name, but you never know, it's quite possible. Then let's also add in a level for our Pokemon, because apparently Pokemon have levels. So we'll go ahead and make it an integer field, again, there's a bunch of different integers. We could do integer field, big integer, small integer, positive big integer. Let's just keep it simple and do a regular integer field. And we're gonna leave the inside. Actually, we can also set a default value. So I'm just gonna say that like every single Pokemon starts out at level 1. That's it. This is basically all that we have to do in order to create a table in SQL using Django. But there's a couple more steps. But this is all the coding that we have to do. The first thing that we need to do is tell Django, hey, this Python class called Pokemon is new. Like, I just created it. Django, you need to start writing code to take this Pokemon class and turn it into something that we can use in SQL. And we do that by doing something called Python manage.py make migrations. So what making migrations does is it tells Django, hey, go check all the files, see if anything has been changed since the last time relating to the models. Where models, again, is Django speak for stuff that has to do with SQL tables. So hit enter. Oh, okay, here, we'll take out min length. I guess it didn't like that. Let's try that again. Make migrations. Go ahead and error checking consistent migration history. Database Pokédex DB1 does not exist. It should. Okay, let's change Docker. I'm gonna close down. Okay, let's just change this back to regular Pokédex DB, and I'll do the same thing for the Docker file, since it apparently doesn't like this new one. And let's just rerun the Docker compose. And we'll rerun make migrations. Okay, perfect. So we've created our models.py. And now that our migrations have been created, and Django now knows, hey, I need you to create something. And we can see in here what this migration looks like. So it essentially says, hey, I need you to create a table with the name Pokemon that's got an ID, it's got a name, and it's got a level. So now we're going to hit migrate, which basically tells Django, all right, now that you know that I've created a table, I want you to push this table up to SQL. Now, you guys will not see no migrations to apply. You guys should see a different message because I've already created the table. But essentially, you should not get a failure. And what we should see is that a table has actually been created. Now, how can we check whether a table has indeed been created or not? This is where we go back to Docker exec. So here's the default code for Docker exec that is from the example. I'm just going to change it to reflect my actual container name, which is week 12, day 1, database 1. And again, this is just your normal Docker exec. All we're saying is I want to exec the container that has this name, which is the default name that Docker Compose has given. It's going to go to, I want to open up Postgres, accessing via port 5432 in my username Postgres, and I want to go into the Pokédex DB. We hit enter. We are indeed inside Pokédex DB, and let's go ahead and see what's in my tables. So we have a bunch of different relations. Most of these, or actually all of these, are created by Django by default. So like this auth group, Django admin log, Django migrations, do not worry about those at this stage. We will play around with authentication in like a month or maybe a little more. Admin log, you guys will see it probably next week. The main thing I want you guys to look at though is this table down here, Pokemon app Pokemon. Hey, that doesn't look like a auto-generated name. That looks like something that has a name related to the app and the model. And if you thought that, you would be right. So why did it create a table called Pokemon app Pokemon? Well, we are using a model created in Pokemon app called Pokemon. If you combine those together, you get Pokemon underscore app, which is the name of the name of the app. And you combine that with the name of the table, Pokemon app Pokemon. That looks like a good table name. Now, what I want to do is let's go ahead and take a look at what's inside of this table. Okay, forget about the one row. That was data that I added in to play around with it. The main thing is we indeed have 3 columns. We have the ID, right, which again is our Django auto-created primary key. We have the name, which is that custom field that we set up, and the level, which is the other custom field that we set up. So, hey, it looks like Django did its magic, and we now have a database created in SQL via Python, which I still think is the coolest thing. Like, you can use Python to create and play with these SQL databases. Like, to me, that's awesome. Okay, now you see here I have some sample data involved. How did I get that there? And more importantly, how can you put sample data in? Well, there's a couple ways. The first thing that we can do is that boring insert into Pokemon app values method. Okay, great. Do that 100 times to manually enter your data. We're using Python now. We're not doing SQL. So that's boring. Instead of that, what we're going to do is learn how to use Django's shell. Because remember, Django, the manage.py, if you guys go back to that file, it's a command line utility. So manage.py has a shell capability built into it. So let's see what that looks like. So we have manage.py, we got a shell. We'll close out of this for now. Close. Let's go ahead and try adding some stuff to our little table. So the first thing that we need to do is import our model. Now remember, we are still located in this overall area, like in the high level root directory of week 12 day 1. It's what I called it. We need to figure out how to get this model into our shell. And the way we can do that is by using handy dandy import statements. So recall that if we want to import a class, we say from and then find the file. So we'll say from models.py import Pokemon. Because again, Pokemon, remember, our models in Django are things that let us create tables or classes at the end of the day. And we hit enter, and it says no module named models. That's weird. Where could it be? Well, number one, the directory I'm in for manage.py is outside of Pokemon app. So I'm going to need to say from Pokemon app / models.py import Pokemon. Oh, here, let me take out the .py. Am I messing up the slash? Oh, it's supposed to be a dot. That's why. Okay, 3rd time's a charm. Perfect. So again, remember, this is Python that we're dealing with. So syntax is not your file structures anymore, is file structure syntax, but we're not using slashes anymore. We're using dots to jump between the different folders. So we're going from manage.py, we're going into Pokemon app, into our models, and we're yoinking out this Pokemon class. Okay, great. I have a Pokemon class. Now what can I do? Well, if we have the Pokemon class, we can leverage the Pokemon class in order to create a model and essentially create a row in our table. So let's go ahead and create a Pokemon. So we'll say like my Pokemon is going to be a brand new Pokemon. Does anyone have a favorite Pokemon that they want to create? Or any Pokemon?
Charizard. That's a good
Charizard. Okay, that's a good one. Name is Charizard, and we'll make its level like 45 because that was a random number. Okay, cool. Let's save that. Well, we have a Pokemon, its name is Charizard, and its level is 45. However, just creating your Pokemon like this does not save it to the database. I can, let's see. Let me open up a new terminal real quick, and I can show you guys that. So, where is my Docker exec code? Go to the bash, and let's run it. Oh, that's right. I'm in a separate shell. That's probably why it doesn't like it, and it's also using bash. Okay, well, let's forget about that for now. But trust me that if we were to exit out of this, we would not be able to see your Pokemon inside the table. The reason for that is because we haven't saved our changes. We haven't told Django, hey, the Pokemon that we just created, we need to save it to the database, not just in Python. The way we can do that, my Pokemon.save, which quite literally saves what you have and puts it into the database from Python. Okay, now we can, there is a way within the console to see what's inside, and we can do that by saying Pokemon.objects.all, which shows you the objects inside your database. This does not look like very much right now, and it will not look like very much for tonight because what a query set is or how to extract a Pokemon object is outside of tonight's scope. But what I hope to show you guys is at the beginning, we only had one Pokemon object in there, which was something that I made before. Now we have two. So we've just used the Python shell, because again, this is Python, this is Python, this is Python. We've just used Python in order to successfully add to a SQL database without ever writing a single piece of SQL code, which I think is really cool. All right, but let's go ahead and enter into our database real quick, and let's just see if our table has two Pokemon in it. Ta-da! Looks like it does indeed have two Pokemon in the table. So, in conclusion, what is Django? Django is Python. Why do we use Django? Because it gives us a really nice and simple way to connect our database to SQL. How do we use it? Well, first we have to create a project, then we have to create an app. After we create the project and the app, and in our Docker Compose, we say, hey, I'm kicking open a database. We go to our settings and we tell Django, number one, that we've created an app. Number two, after we created the app, that we have a database that we're now using. After we tell Django that we have a database, we now go into our models and we tell Django, hey, I'm going to write Python code to create a table, which in our case is the Pokemon table, that has a bunch of different rows. We can then use make migrations and migrate in order to tell Django, hey, just so you know, I updated the stuff that I want to go in those SQL tables. So can you push the changes? And by running make migrations and migrate, Django will take this stuff and it will turn it into SQL code. From there, you're happy to go into your database using Docker exec and see stuff inside it, or you can use the Django Python shell by using python manage.py shell, and you can check what's inside it using using the object.all command, Or you can add stuff by creating a new instance of your model and then saving it to the database. In a nutshell, Django right now probably seems really complicated, and there's a lot of words and a lot of tools and a lot of files. But in like a week or two, you guys are going to be absolute masters at using it, and it will simplify your life so much when dealing with SQL databases. That's it for lecture.